Hello students and welcome to Math Weekly number 12.
In this Math Weekly, our focus skill will be on identifying the dilation factor. A dilation factor, by definition, is a ratio used to perform a dilation, which is a change to a shape size. Here are some facts about dilation factors. A dilation factor will either be greater than 1 or less than 1, which would be a fraction. A dilation factor greater than 1 will indicate an enlargement has occurred, meaning the dilation is bigger than the original figure. A dilation factor less than 1 will indicate that a reduction has occurred, meaning that the dilation is smaller than the original figure. In order to determine the dilation factor, write a ratio of corresponding lengths. Be sure to use the dilation size over the original size. A hint to use is to either use a vertical segment or a horizontal segment. Avoid using diagonals as you cannot easily count that length and would need to use the Pythagorean theorem to determine those lengths. So use either vertical or horizontal segments. So let's look at an example. What dilation factor was used to transform pentagon EFGHI to pentagon E1F1G1H1I1? So a dilation factor is the dilation size to the original size. So for this, I need either a vertical line or a horizontal line. So I could either use segment G1H1 and GH, or I could use FG or an F1G1. Either one would give me the same exact dilation factor. I'm going to go ahead and use FG. So I'm going to count the boxes of the length of segment FG. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And segment FG is from the original figure, so I'm going to put that 9 on the bottom of my dilation factor. Now I'm going to figure out the length of F1G1, which will be our dilation size, and that is 1, 2, 3 blocks. So I'll put a 3 on the top. Now, my dilation factor is 3/9, but I can reduce that by 3 to get a dilation factor of 1/3. So the dilation factor used to transform pentagon EFGHI to pentagon E1F1G1H1I1 is 1/3, which makes sense because remember, a dilation factor less than 1 indicates that a reduction has occurred, and the dilation, the changed figure, is smaller than the original. Now let's look at an opposite example. What dilation factor was used to transform triangle ABC, which is the smaller one, into triangle DEF, which is the larger one? Because our after image or our dilation is bigger, we know that our factor will be greater than 1. So remember, our dilation factor is the dilation size over the original size. Our original figure was this small one, ABC, and we only have one horizontal or vertical segment, which is segment AC, which is horizontal. So count the digits, 1, 2, 3. That length is 3, so the bottom number of our dilation factor is 3. Now, the dilation is the resulting image, so that's triangle DEF. Segment ED corresponds with AC, it's just been rotated, and its length is 1, 2, 3, 4, 5, 6. So 6 goes in the numerator. So our dilation factor is 6/3. Because 6 can divide by 3, we can reduce this to the whole number 2. So the dilation factor used to transform triangle ABC into triangle DEF was 2, which makes sense because this was an enlargement So this number should be more than 1. So what we've learned in this Math Weekly is dilation factors describe how a shape's size changes. A dilation factor greater than 1 signals that an enlargement has occurred, and a dilation factor less than 1 indicates that a reduction has occurred. Remember, the dilation factor is the dilation size over the original size.